You've heard the promises, right? A future with brilliant AI assistants that handle anything you throw at them. But so far, the reality has been, well, a little messy. We've seen a string of expensive, high-profile flops. So what gives? In this explainer, we're going to look at why building the AI of the future is less about some kind of magic and a whole lot more about a brand new and incredibly challenging type of engineering.
I mean, we've all seen the sci-fi movies, but the actual launch of AI agents has been a series of spectacular misfires. You've got Do Not Pay, the so-called robot lawyer that got fined by the FTC because it, just didn't work. And then there's the Humane Pin and the Rabbit R1, both super hyped, both plagued by major reliability problems in the real world. The dream of that perfect assistant? Yeah, it still feels pretty far off.
So the big question is, why is this so hard? It's not really about making the AI smarter in the way we usually think. It really comes down to this fundamental conflict, a tug-of-war that every single AI engineer is dealing with right now.
And that conflict is all about two words that sound similar but are worlds apart: capability and reliability.
Okay, first up, you have capability. This is the stuff that gets you excited. It's what you see in those slick demos, the proof that a model can do something amazing, at least that one time. It's that flash of brilliance, that wow moment that shows the potential.
But then you have reliability, and this is all about consistency, getting it right every single time out in the messy, chaotic real world. This is what users actually need for a product to be useful, not just a cool tech demo.
Think about it like this. Getting a model to work 90% of the time is a huge technical achievement. It shows massive capability. For a long time, this was basically the job of a machine learning engineer. Get the model to be right most of the time.
But for a real product that people depend on, 90% is a catastrophic failure. Imagine your food delivery assistant messing up 1 out of every 10 orders. You delete the app in a second. For a product to actually work, you need what they call 5 nines reliability, 99.999% accuracy. And that gap, that massive chasm between works sometimes and works every single time, well, that's where this new field of AI engineering lives. Their entire job is to build a bridge over that chasm, to turn that impressive capability into rock-solid reliability.
To really get why this reliability gap is such a beast, we need to quickly pop the hood and look at how the brain of these agents, the large language model or LLM, is actually built. It's really a two-stage process. First is pre-training. This is where the model basically speed reads a huge chunk of the internet. It gives it this incredible, vast knowledge base, but it also means it absorbs all the noise, the junk, the bias, the total unpredictability of the web. Then comes fine-tuning. This is like sending it to finishing school to learn how to be a polite and helpful assistant. But all that does is put a friendly mask on top of the underlying chaos.
So you're an engineer. You have this incredibly powerful but fundamentally unpredictable brain. How in the world do you build a dependable system on top of that? Well, you use a specialized toolkit designed to wrangle that chaos into something you can actually count on.
This toolkit really has 3 main parts. First, you have to completely rethink how you even measure if the agent is any good. Second, you have to connect it to the real world, to a source of truth. And third, you have to protect it from being manipulated. Let's break those down.
All right, first, evaluation. For a long time, we used these static, standardized tests, but they can be super misleading. Take the coding agent Devin. It scored great on a benchmark test, but when it was given 20 real-world tasks, it only actually succeeded on 3 of them. So the new way is to use multidimensional metrics, looking at the trade-offs between things like accuracy and cost. It gives a much more realistic picture of how an agent will actually perform when it really matters.
Next, to make the model more reliable, engineers use techniques like retrieval augmented generation, or RAG. This one is absolutely critical. It basically connects the LLM to an external, factual database, like a library, and forces it to look things up before it speaks. This grounds the model in reality and dramatically reduces the odds of it hallucinating, which is just a fancy way of saying confidently making stuff up.
But even if your model is grounded in facts, you're not totally safe. Because the model's fundamental nature, its desire to be helpful and to follow instructions, can actually be turned against it. It's an open door for an attack.
And you've got to see this. This is a famous example of a jailbreak prompt. A user tricks the model into bypassing its own safety rules by wrapping a really dangerous request inside this emotional, sentimental story. See, it's not a bug in the code. It's an exploit of the model's helpful personality.
You're coaxing it to give you information it knows it's not supposed to.
So you have to evaluate differently, ground your model in reality, and then defend it from attack. This isn't just a few new things on a to-do list. Tackling these challenges requires more than just a new toolkit. It demands a fundamental shift in how we even think about building software. Building with AI is not like traditional software engineering, where your code is predictable and does the same thing every single time. It's much more like reliability engineering for a complex, unpredictable, or stochastic system. The job isn't to write perfect code, it's to manage and build guardrails around this powerful but inherently chaotic component.
And what's amazing is that this isn't the first time we've faced this kind of problem. Go back to 1946 and the engineers building the ENIAC computer. They had the exact same challenge. How do you build one single reliable machine out of 17,000 notoriously unreliable vacuum tubes, where any one of them could fail at any given moment?
Their job was to create reliability out of chaos. And today's AI engineers? They're picking up that very same mantle. They're just taming the billions of unpredictable parameters inside a language model instead of thousands of faulty vacuum tubes. They are creating dependability from chaos. The core engineering challenge, it turns out, is timeless.